Section 4.3. Top 10 Programming Features You Need to Know. Part 1. We're going to give you a whirlwind tour of the 10 Python features that you'll need for the rest of your programming journey, starting with the first 5 of those in this chapter. Python is an interactive language, which makes it easier than other languages for us to play around with and see what stuff does. We'll take advantage of that here as we explore programming features. This is how the two of us learned Python and how many thousands of programmers have done so. Don't hesitate to experiment. To get started, press Ctrl-Shift-P and type REPL, and then select Python. Start REPL. This should result in the situation shown in Figure 4.5. REPL stands for Read, Execute, Print Loop. It's called that because Python reads what you type, executes or runs it, prints the results back to you, and does all of this over and over in a loop.
Figure 4.5. Starting REPL from VS Code.
This will put you back at the same Python prompt as in Chapter 3, as shown in Figure 4.6, except with none of your functions loaded.
Figure 4.6. REPL running in VS Code.
Then we can start typing Python code. For example, type
See this code?
and press Enter. You'll see the response of 20. We won't spend time on simple math here, but the way you interact with Python to learn how it works is exactly the same. You type some code, and Python responds. Now, let's jump into the first 5 of those 10 Python features we mentioned. Section 4.3.1. Number 1. Functions. You learned all about functions in Chapter 3, so let's just summarize what we learned. You use functions to break a large problem into smaller pieces. In retrospect, that best word function we wrote in Chapter 3 is a pretty big task. It has to figure out which word in a list of words is worth the most points. How many points is a word worth? Aha! That's a subtask that we can carve out from this function, which we did in our earlier numPoints function. We design a function to take parameters, one parameter for each piece or collection of data that the function needs to do its job. After doing their work, most functions use return to send the answer back to the line of code that called them. When we call a function, we pass values, known as arguments, with one value for each parameter, and we often store that return value using a variable. For each program we write, we'll likely need to design a few functions, but there are also some functions that are built into Python that we get for free. We can call those like we call our own functions. For example, there's a built-in max function that takes one or more arguments and tells us the largest.
See this code?
There's also the input function, which we used in our getStrongPassword function from Chapter 3. It takes an argument that becomes the prompt to the user, and it returns whatever the user types at the keyboard.
See this code?
If input is the function to receive input from the keyboard, is there an output function to output a message to the screen? Well, yes, but it's called print, not output.
See this code?
Section 4.3.2, number 2, variables. A variable is a name that refers to a value. We used variables in Chapter 3 to keep track of return values from functions. We also just used a variable here to hold the user's name. Whenever we need to remember a value for later, we use a variable. To assign a value to a variable, we use the equals sign symbol, which is called the assignment symbol. It figures out the value of whatever is on the right and then assigns that to the variable.
See this code?
The equals symbol is different in Python than in math. The equals sign is used in Python and other programming languages to denote assignment. The variable on the left side of the equals symbol is given the value of the calculation performed on the right side of the equals symbol. This is not a permanent relationship, as the variable can have its value changed. People new to programming who are strong in math can find this confusing, but just remember that the equals sign in Python means assignment, not equality. We can use the variable in a larger context, called an expression. The value that the variable refers to gets substituted for its name.
See this code?
Variables persist in the Python prompt. We assigned age in the earlier batch of code. Why can we keep referring to it? Any variable declared during a session of programming with your Python prompt will stick around until you quit. That's just how variables work in programs too. They're available as soon as you assign a value to them. But notice that the variable age didn't change when we said age plus 3. To change it, we need another equals assignment statement.
See this code?
Let's see a few more ways to change what a variable refers to. We'll include some explanations as annotations with the code.
See this code?
Section 4.3.3, Number 3, Conditionals. Whenever our program has to make a decision, we need a conditional statement. For example, in Chapter 2, we needed to make a decision about which players to include in our data. We wanted only quarterbacks. To do so, we used if statements. Remember our larger function from Chapter 3? We've reproduced it here in the following listing.
Listing 4.2. Function to determine the larger of two values.
The if-else structure in listing 4.2 is known as a conditional statement, and it allows our program to make decisions. Here, if num1 is greater than num2, then num1 is returned, otherwise num2 is returned. That's how it returns the larger one. After if, we put a Boolean condition, num1 greater than num2. A Boolean condition is an expression that tests a condition where the result would either be true or false. If it's true, then the code under the if runs. If it's false, then the code under the else runs. We create Boolean expressions using comparison symbols such as greater than or equal to equals for greater than or equal to, less than for less than, greater than for greater than, double equals for equal to, and exclamation mark equals for not equal to. Notice that we're using indentation not only for the code of the function, but also for the code of the if and else parts of the if-else statement. Indentation is necessary for the code to function properly, so it's worth paying attention to. We talk more about indentation in the next chapter. This is how Python knows which lines of code belong to the function, and which additionally belong to the if or else. We can play around with conditional statements at the Python prompt too. We don't need to be writing code inside of a function. Here's an example.
See this code?
You'll notice that the prompt changes from 3 greater than symbols to 3 dots when you're typing inside the if statement. The change of prompt lets you know that you're in the middle of typing code that you need to complete. You need an extra press of enter when you're done with the else code to get out of the 3 dots prompt and back to the 3 greater than symbols prompt. We set the age variable to 40. As 40 less than 40 is false, the else runs. Let's try again, this time making the if run.
See this code?
You might see some if statements with no else part, and that's okay. The else part is optional. In that case, if the condition is false, then the if statement won't do anything.
See this code?
Notice that the way to test whether two values are equal is to use two equals signs, double equals, not one equals sign. We already know that one equals sign is for the assignment statement to assign a value to a variable. What do you do if you have more than 2 possible outcomes? For example, let's say that a person's age determines the show they'll likely binge, as shown in Table 4.1.
Table 4.1. Possible favorite TV shows by age.
We can't capture all of these outcomes with just an if-else, so the elif, short for else if, allows us to capture the logic for more than 2 possible outcomes, as shown in the following code. We're presenting this code without the Python prompts, 3 greater than symbols and 3 dots, because this would be a lot to type.
See this code?
We're using AND to capture a complex condition. For example, in the first line, we want age to be greater than or equal to 30, and less than or equal to 39. Python works from top to bottom, and when it finds a condition that's true, it runs the corresponding indented code. Then, it stops checking the remaining elifs or else. So if 2 conditions happen to be true, only the code for the first one would run. Try experimenting with various values for the age variable to observe that the correct code runs in each case. In fact, if we were serious about testing this code, we could use the if statement structure for a good sense of the values we'd want to test. It's all about testing the boundaries of values. For example, we definitely want to test the ages 30 and 39 to make sure, for example, that we're correctly capturing the full 30 to 39 range with the first condition. Similarly, we'd want to test 20, 29, 10, 19, 0, 9, and then something larger than 39 to test the else way at the bottom. If you use additional ifs rather than elifs, then they become separate if statements, rather than a single if statement. This matters because Python always checks each independent if statement on its own, regardless of what may have happened in previous if statements. For example, let's change the elifs to ifs in our age code. That gives us the following.
See this code?
Suppose that you put age equals 25 above this code and run it. what do you think will happen? Well, the second if condition age is greater than or equal to 20, and age is less than or equal to 29 is true, so we'll certainly output binging the office. But that's not all that happens. Remember, because we're using ifs here, each of the remaining ones is going to be checked. If they were elifs, we'd be done. Age is greater than or equal to 10 and age is less than or equal to 19 is false, so we're not going to output binging Pretty Little Liars. The final if condition age is greater than or equal to 0 and age is less than or equal to 9 is also false, so we're not going to output binging Cheese Sweet Home. But this if has an else. So, we are going to output what's binging. We didn't intend this. We only wanted what's binging. For people whose age is at least 40. This is all to say that if and elif behave differently, and that we need to be using the one that matches the behavior that we want. If we want multiple chunks of code to potentially run, and elif if we want only one. Section 4.3.4, number 4, strings. As we learned in Chapter 3, a string is the type we use whenever we want to store text. Text is everywhere, stats like in Chapter 2, passwords, books, so strings show up in almost every Python program. We use quotation marks to indicate the beginning and end of the string. You'll see Copilot use double quotes or single quotes. It doesn't matter which you use, just be sure to start and end the string with the same type of quote. Strings come with a powerful set of methods. A method is a function that's associated with a particular type, in this case, strings. The way you call a method is a little different from how you call a function. When you call a function, you put the argument values in parentheses. With methods, we still put values in parentheses, but we need to put the value on which we're calling the method first, outside of the parentheses, followed by a dot. We'll see an example of that next. In Chapter 3, Copilot used some string methods to implement isStrongPassword. Let's try using those methods here to gain a better understanding of how they work.
See this code?
There are many other string methods as well. Some help you convert strings between lowercase and uppercase, others help you search a string, and still others help you format a string, for example, centering or right justifying it. Copilot's explain feature can often be helpful if you're not sure what a given string method does. For example, what does this function do?
See this code?
Remember that we can ask Copilot to explain code, as we demonstrated in Section 4.2. Here's what we got when we asked Copilot to explain this code. The provided Python code defines a function named cleanNumber. This function is designed to take a single argument, phone number, which is expected to be a string representing a phone number. The purpose of this function is to remove certain characters from the phone number string, specifically parentheses and hyphens. The function uses the replace method, which is a built-in method in Python for strings. The replace method replaces a specified phrase with another specified phrase. It takes two arguments. The first is the substring that needs to be replaced, and the second is the substring that will replace the first substring. In this function, the replace method is called 3 times on phone number. Each call to replace is used to remove one type of character. First the open parenthesis, then the close parenthesis, and finally the hyphen. It does this by replacing these characters with an empty string, effectively removing them. After all replacements are done, the cleaned phone number is returned by the function. This will be a string containing the digits of the phone number without any parentheses or hyphens. This function could be useful in situations where you need to process or store phone numbers in a consistent character-free format. For example, you might want to remove these characters when storing phone numbers in a database or when comparing phone numbers for equality. That confirms what this function does, removes parentheses and hyphens from a phone number string, and it uses the replace method to do so. Wait, replace sounds like we're changing some characters to some other characters, replacing them, not removing them. How is replace able to remove characters for us then? The explanation said, it does this by replacing these characters with an empty string, effectively removing them. That's a clue to how replace is doing this, but we might want to know more. We therefore next use the prompt, how does the replace method use the empty string to remove characters? And received the following explanation from Copilot. The replace method in Python replaces all occurrences of a specified substring in the string it's called on with another specified substring. In this case, the specified substrings are the characters open parenthesis, close parenthesis, and hyphen. The method is called on the phone number string, and the second argument to replace is an empty string. So, what happens is that every occurrence of the specified character and phone number is replaced with an empty string. This effectively removes that character from the string, because replacing something with nothing is equivalent to removing it. This is done 3 times in the clean number function, once for each character that needs to be removed. After all 3 characters have been removed, the cleaned phone number is returned. And if you wanted to learn even more, you could continue asking Copilot questions or do your own testing at the Python prompt. For example, you could verify that replace removes all open parenthesis, close parenthesis, and hyphen characters, even if there are multiples of each. And you could explore using replace to actually replace characters, its typical use case, rather than removing them. This kind of exploration is also helpful if we need to separate truth from bits of incorrect information that Copilot may provide. This is why we need a baseline of our own Python knowledge. You'll also often see what look like mathematical operators being used on strings. They are the same as math symbols, but they do different things on strings. The plus operator is used to put 2 strings together, and the asterisk operator is used to repeat a string a specific number of times. Examples are shown here.
See this code?
Section 4.3.5. Number 5. Lists. A string is great when we have a sequence of characters, such as a password or a single Scrabble word. But sometimes, we need to store many words or many numbers. For that, we need a list. We used a list in Chapter 3 for the best word function because that function needed to work with a list of individual words. Whereas we use quotation marks to start and end a string, we use opening and closing square brackets to start and end a list. And as for strings, there are many methods available on lists. To give you an idea of the kinds of list methods available and what they do, let's explore some of these.
See this code?
Many Python types, including strings and lists, allow you to work with particular values using an index. You need to use indices whenever you want to work with part of a string or list rather than the whole thing. An index is just a number that identifies an element. Indices start at 0 for the first element and go up to, but not including the number of values. The first value has index 0, not index 1. The second has index 1, the third has index 2, and so on. The last value in the list is at the index, which is the length of the list minus 1. The length of the list can be determined by using the len function. For example, if we do len of books, we'll get a value of 4. So the valid indices are from 0 up to and including 3. People also often use negative indices, which provides another way to index each value. The rightmost value has index minus 1, the value to its left has index minus 2, and so on. Figure 4.7 depicts this example with both positive and negative indexing.
Figure 4.7. List elements can be accessed through either positive or negative indices.
Let's practice indexing on the current books list.
See this code?
There's also a way to pull multiple values out of a string or list, rather than just one. It's called slicing. We specify the index of the first value, a colon, and the index to the right of the value, like this.
See this code?
We specified 1:3, so you might expect to get the values including index 3. But the value at the second index, the one after the colon, isn't included. It's counterintuitive, but true. If we leave out the starting or ending index, Python uses the start or end as appropriate.
See this code?
We can also use indexing to change a specific value in a list, for example.
See this code?
If we try that on a string, though, we get an error.
See this code?
A string is known as an immutable value, which means that you can't change its characters. You can only create an entirely new string. By contrast, a list is known as a mutable value, which means that you can change it. If you get errors about a type not supporting item assignment, you're likely trying to change a value that can't be changed. In this chapter, we introduced you to 5 of the most common code features in Python. We'll continue with 5 more in the next chapter. We also showed you how you can use the Copilot explanation tool to help you understand what the code is doing, and offered guidance for verifying the veracity of these explanations. Table 4.2 provides a summary of the features we covered in this chapter.
Table 4.2. Summary of Python code features from this chapter.